Hello, everyone. Um, this is an introduction and a series of questions about our newest topic, Lesson 9-1 on exponential functions. It's so important to me that just because we're doing the distance learning during this time period doesn't mean that we give up on our core idea of inquiry, just asking questions in mathematics and letting our curiosity lead us, as opposed to simply just being told or prescribed ideas and thoughts. That's just something I can't get behind, and I truly don't think that's the way that the brain functions or that you function. So this is a pretty short video where I just want us to take a look at three different scenarios or situations, and I want to pose a series of questions, and I'd like you to think about those questions and maybe do some writing about them, and then I'll post a document and another video where I reveal some of my thoughts and some of my answers. So here we go. Um, my guess is that all of you, probably in middle school or at some point in your math career, or perhaps even in science, this comes up quite a bit in science, have learned about exponential relationships. And I don't want to define what they are for you just yet. I'm curious to see what resides in your brain and whether you have some intuition around it. So, right now you should be looking at this image that I have on my computer screen. This is the NCAA men's tournament bracket for the year 2019. You may know that all sports were canceled, unfortunately, this year, so that tournament did not happen this year. So we're looking at last year's tournament bracket, and it's pretty overwhelming. There's a lot of stuff going on here. This tournament is a major deal every year. It makes the schools hundreds of millions of dollars and the networks as well. But the reason I'm having you look at it is because I want to ask you a question. That question is simply, do you see any exponential patterns in the table? And I don't want to kind of tell you where to look at the table or what sections to look at the table. I can tell you that right in the center you have the winner of last year's tournament, and that was Virginia. And I can tell you that you should probably begin looking at the outsides of the brackets to make sense of what's going on. But you'll notice that there are some scores here, and I'm quite confident that you can make sense of the bracket and then really focus in on the question, are there exponential patterns emerging here in the table? So that's scenario number one. Scenario number two comes from the world of mythology. Some of you may be familiar with the story of Hercules. Hercules is hated, I think, by Hera. She despises him because his father is Zeus. In any event, he murders his wife and his two children in a rage and is seeking penance. And so his penance is to complete these 12 labors. And one of those labors is to fight this monster, this Hydra, this many headed serpent. So Hercules is not generally known for being the sharpest tool in the shed. And when he first encounters the beast, he kind of just blindly begins to lop off its heads, thinking that that's the way to kill it. The only problem is, wherever he lops off a head, two more grow in its place. So this premise that I'm kind of describing to you, this idea that where he chops off one head, two more grow in its place, I'm suggesting that this has something to do with exponential relationships. So kind of a cool exercise to conduct on your own is to model this situation, and I've started that for you here. And I'm just using these dots to represent Hydra heads, and I'm imagining that Hercules is fighting just one of these serpent heads, and I'm calling these steps phases. So, he comes along and he chops off this head, and two more grow in its place. So, at phase one, he is no longer battling one Hydra head, he's battling two. And so, not doing a lot of thinking, he continues to just blindly chop off heads. Where he chops off this head, two more grow in its place, and where he chops off this head, two more grow in its place. So you're seeing that very quickly Hercules is creating a problem for himself, where he was initially just fighting one head, and the number of Hydra heads keeps on increasing pretty quickly. So much so that by the time I get to this phase five, he's got more heads than he knows what to do with. He went from 16. I didn't even finish this row because the number of dots and the number of branches is getting out of control. So I'm curious to see, again, what is the exponential relationship here? What is it about this situation that is exponential in nature? It'd be good if you could think about that and perhaps continue the table for a bit. And then our final situation or scenario or thing that I want you to think about is this set of graphs where I have graphed the function f of x equals 2 to the x, and I have graphed the function g of x equals 1/2 to the x. And here you can see those graphs. And I'm asking you to conduct a notice and wondering session of your own on this, where you kind of list out things that you notice about these graphs and you list out things that you're wondering about these graphs. And I think it's, we've done this for many of the relationships we've studied. Of course, it's easier when we do this as a class, but I think there's still great value in trying this on your own and asking yourself, okay, Mr. Hojad is claiming that both of these relationships, both of these curves are exponential. Now, what am I noticing and what am I wondering about them? So those three scenarios are the ones I'd like you to be thinking about. And again, like I said, I'll be posting a follow-up video where I share with you some of my own thoughts on these very questions. Good luck. I hope that it goes well, and I hope you get